It is hi myself Arun. Myself Arun. Okay. Hi myself Arun. I'm working as a full-time trainer. Okay. Let us start today's class.
Yes, that's it.
Let us start the class. Okay. Record చేస్తున్నాను call అందుకని. I'm recording the call. Okay. Myself Arun. I'm working as a full-time trainer. So I will be teaching the technologies called C, C++, .NET, SQL and database courses. So today's class we'll be talking about the data structures. Okay. Today's class we'll be talking about the data structures. Okay. Data structures. So I will be sharing the screen. I'll be sharing the screen. Okay. So initially, what is meant by data structure? Okay, what is meant by data structure? So data structure is nothing but the name itself is saying that the name itself says that data structure, that is meant by structuring the data. Data structure is nothing but structuring the data. So we can also say the definition of the data structure as organizing the data in a sequential order. That is, అంటే ఫర్ ఎగ్జాంపుల్ మనకి ఫర్ ఎగ్జాంపుల్ డేటా స్ట్రక్చర్ ఉందనుకోండి, మనకి లిస్ట్ ఆఫ్ ఎలిమెంట్స్ ఉన్నాయనుకోండి, లిస్ట్ ఆఫ్ ఎలిమెంట్స్ని అరేంజ్ చేస్తామంట, సీక్వెన్షియల్ ఆర్డర్లో అరేంజ్ చేస్తామంట. దట్ ఈస్ మీన్ డేటా స్ట్రక్చర్. ఓకే, డేటా స్ట్రక్చర్ ఈస్ అ ప్రాసెస్ ఆఫ్ ఆర్గనైజింగ్ ద డేటా ఇన్ సీక్వెన్షియల్ ఆర్డర్. ఓకే, so coming to the advantages, coming to the data structure is consists of a collection of elements. Okay, data structure consists of a collection of elements. Data structure consists of a collection of elements. Okay, so we'll be organizing the data in a sequential order. We'll be organizing this list of elements in a sequential order. Okay, that is meant by data structure. Okay, the name itself says structuring the data. Structuring the data. Data structure means structuring the data. So we'll be organizing the data in we'll be taking a list of elements. Okay, we'll be taking a list of elements and we'll be organizing the data in a sequential order. We'll be organizing the data in a sequential order. Okay, that is meant by data structure. And coming to the types of data structure, coming to the advantage of the data structure, so I will write the advantage of the data structure. Advantage of the data structure. The advantage of the data structure. The first advantage of the data structure is it consists of it consists of a collection of elements. Collection of or it consists of elements. Collection of or it consists of a list of elements. Okay, it consists of a collection of elements or it consists of a list of elements. Okay, the first advantage of the data structure is it consists of a collection of elements or it consists of a list of elements. Okay, so for example, the best example we can take as an array. So example take as an array. Example we can take as an array. So in an array, what will happen? In an array, list of elements, present. Taking the list of elements. Okay, we'll be taking a list of elements or collection of elements. The best example we can take an example of data structure is we can take an example of an array. So the example of an array, what will array will be consisting of? An array will be a list of elements, okay, or else a collection of elements. So the actual definition of the array is it is a collection of elements where we will be storing the elements in of the common data type. We will be taking a list of elements which are of common data type. Okay, that is when an array. So we will be taking a list of elements which are of common data type, which are of single data type. Okay, so individual data type. Okay, an array will be consisting of a common data type. An array common data type. Array consists of common data type. That is an example. So okay. So the first advantage of the data structure it consists of a collection of elements or list of elements. It consists of a collection of elements or list of elements. Okay. So the best example we can take as an array. So in an array, a list of elements is present. That is, we will be taking a list of elements or collection of elements. That is, one or more elements we can store in an array. We can store one or more elements in an array. Okay, and also only one common data type of elements are present. Only one common data type of elements are present. That is the first advantage. And coming to the second advantage, can arrange the elements. Can arrange the in a sequential order. Can arrange the elements in a sequential order. We can arrange the elements in a sequential order. Okay. So the second advantage is we can arrange the elements in sequence. That is, we can order the elements. We can order the elements in a continuous memory locations. And also another point is in an array we can order the elements. We can arrange the elements. Continuous continuous in an array, we can arrange elements in a continuous memory location. So we can arrange elements in a sequential order. The second advantage of the data structure is we can arrange the elements in a sequential order. That is, we can place the elements in a continuous memory location. We can place the elements in a continuous memory location. So we can arrange the elements in a sequential order. That is the second advantage. And coming to the third advantage, multiple values are stored in a data structure. Are stored in data structure. Values are stored in data structure. The third advantage is in a data structure multiple values. We can store multiple values. Okay, multiple values are stored in a data structure. That is more than one element. Instead of storing a single value, we'll be storing multiple values in a data structure. Okay, instead of storing multiple single value, we'll be storing multiple values in a data structure. Okay, that is more than one. We'll be storing more than one value in data. Multiple values are stored in a data structure. And fourth one is memory for the element. Memory for the data structure. Memory for the data structure allocated automatically by the system. This is allocated dynamic memory allocation. Dynamic memory allocation. That is allocated. Okay. So we can allocate the memory automatically by the system. The system itself allocates the memory. Okay. The system itself allocates the memory. The fourth advantage is memory for the data structure is allocated automatically by the system. Okay. The system itself allocates the memory. That is the fourth advantage. Okay. So we are having four advantages in data structure. What is the first advantage? It consists of a collection of elements or list of elements. It consists of a collection of elements. Okay, that is multiple elements. More than one element we can store in a data structure. More than one element we can store in a data structure. And the best example for a data structure we can take as an array. Okay, so in an array we'll be storing a list of elements. In an array we'll be storing a list of elements. Okay, that is the first advantage. And array consists of a common data type. Okay, and in an array we can, another important point is in an array we can arrange the elements in continuous memory locations. Okay, an array will be consisting of the values in continuous memory locations. An array will be consisting of the values in continuous memory locations. Okay, that is the first advantage. And second advantage is we can arrange the elements in a sequential order. Okay, we can arrange the elements in a sequential order, that is in continuous memory locations. We will be arranging the elements in a particular sequence. That is, smallest value is arranged first and largest value is arranged second. Okay, we can arrange the elements in a sequential order. That is the second advantage. And third advantage is multiple values are stored in a data structure. Okay, in a data structure, we can store multiple values. Okay, multiple values are stored in a data structure. That is list of elements. We are taking a list of elements as an example. Okay, multiple values are stored in a data structure. And fourth advantage is, that is the third advantage. And fourth advantage is memory for the data structure is allocated automatically by the system. Memory for the data structure is allocated automatically by the system. Memory for the data structure is allocated automatically by the system. Okay, the system itself
Sir,
allocates. Hello, చెప్పండి.
is there any difference between first point and third point?
First point and third point. It consists of a collection of elements. Third point multiple values. రెండు సేమేనండి. Multiple values are stored in data. రెండు సేమే. Both are same.
Then why sir two times?
Okay, I've written by mistake. I've written. Okay, so multiple, it consists of a collection of elements or list of elements, and also multiple values is stored in data structure. The first point and third point are same. Okay, so the advantages, first point and third point are same. Okay, multiple values are stored in data structure, or it consists of a collection of elements or list of elements. Okay, so fourth advantage is memory for the data structure is allocated automatically by the system. Memory for the data structure is allocated automatically by the system. Okay, so the system itself allocates memory. The system itself allocates memory. Okay. So these are the four advantages we are having in a data structure. Okay, these are the four advantages we are having in a data structure. Okay, and coming to the types of data structure, coming to now the second point, next point is coming to the types of data structure. Okay, so mainly the data structure is divided into two types. Okay, mainly the data structure is divided into two types. So what are they? First type of data structure is primitive data structure, and second type of data structure is non-primitive data structure. Okay, first type of data structure is primitive data structure, and second type of data structure is non-primitive data structure. Okay, so coming to the first type of primitive data structure, that is called as the primitive data structure. Okay, coming to the first type of data structure called as primitive data structure. So let me discuss the definition. Okay, let me discuss the definition of the primitive data structure. Let me discuss the definition of the primitive data structure. So the first primitive data structure is a type of data structure where we can store only single value. In a primitive data structure, it is a type of the first point. The first type of data structure is primitive data structure. 1 second, I will drink water and come. Okay. 1 second, I will drink water and come. Okay. I will drink water. Hello. So let us come back to class. So coming to the first type of data structure is primitive data structure. Okay. So let me discuss the definition of the primitive data structure. So it is a type of data structure. Okay. Primitive data structure is a type of data structure where we can store only a single value. Okay. Where we can store only single value. So the memory will be allocated only for the single value. Okay. So let me discuss the definition. I will type the definition. So in this data structure, we can store only one value. We can store only one value, one element, one value, one value in the primitive data structure. Okay, so primitive data structure is nothing but it is a type of data structure we can store only where we can store only one value, where we can store only single value. Okay, in this data structure we can store only single value. Okay, that is one important point, the definition of the primitive data structure. And coming to the non-primitive data structure, the definition of the non-primitive data structure is in this data structure we will be storing multiple values. In this data structure, multiple values. Okay. So the second type of data structure. So in this data structure, definition, this data structure can store multiple values. We can store multiple values. Okay. So in primitive data structure, only one value. Whereas in second type non-primitive data structure, we are storing multiple values. Okay, we can store more than one value in our list. We can store only more than one value in non-primitive data structure. Okay, so that is the definition of the primitive data structure and non-primitive data structure. In this data structure, we can store only one value. And second type of data structure, non-primitive data structure. In this data structure, we can store multiple values. That is more than one value at a time. We can store more than one value at a time. Okay, we can store more than one value. We can store than one value at a time in non-primitive data structure. Okay, we can store more than one value at a time. Than one value at a time. Okay, so that is the definition. Primitive data structure is in this data structure we can store only one value. In primitive data structure we can store only one value. Whereas in non-primitive data structure we can store multiple values. That is, we can store more than one value at a time. Okay, we can store more than one value at a time. Okay, that is maybe non-primitive data structure. So these are the two types of data structures we are having. Okay, so first one is primitive data structure, and second one is non-primitive data structure. Okay, so in primitive data structure we are storing only one value. We are storing only single value at a time. We are storing only one value in the list item. Okay, we are storing only one value in the list item. Okay, that is primitive data structure. And coming to non-primitive data structure, we are storing more than one value at a time. In a list of item, in our list item, we are storing more than one value at a time. That is called as non-primitive data structure. Okay. These are the two types of data structures we are having. First one is primitive data structure, and second one is non-primitive data structure. Primitive data structure means we can store only one value at a time, and whereas for non-primitive data structure we can store multiple values. That is, we can store more than one value at a time. Okay, we can store more than one value at a time. That is called as non-primitive data structure. Okay, so coming to the types. So, and another important point is what is the advantage of using a data structure. Okay, what is the advantage of using a data structure? So using a data structure we can perform two operations. Okay, using data structure we can perform two operations. Data structure we can perform in our C programming. Data structure we can perform two operations. Okay, what are the two operations are? First one is searching. First one is searching, and second one is sorting. Searching and second one is sorting. Okay, so using data structure we can perform two operations. That is the use of the data structure. Okay, so what are the two operations are? First one is searching. We can perform searching operation, and we can perform sorting operation. Okay, so what is the meaning of the searching operation? The meaning of the searching operation is that is we can find an element. Okay, so it is the process of searching for an element or finding an element. Okay, searching for an element, searching for an element, or finding an element. Okay, it is the process of searching for an element or finding an element. Okay, that is the definition of the searching. So we are finding for an element, that is అంటే ఒక ఎలిమెంట్ గురించి వెతుకుతున్నాం మనం. సో మనం టూ ఆపరేషన్ సెర్చింగ్ ఆపరేషన్ ఏం చేస్తున్నాం అంటే ఒక ఎలిమెంట్ని ఫైండ్ చేస్తున్నాం అంటే ఒక పర్టికులర్ లిస్ట్ ఉంది అనుకోండి, ఒక 10 ఎలిమెంట్స్ యొక్క లిస్ట్ ఉంది అనుకోండి, ఆ లిస్ట్లో ఆ పర్టికులర్ ఎలిమెంట్ ఏ పొజిషన్ ఉందనేది మనం సెర్చ్ చేస్తున్నాం అనమాట. దట్ ఈస్ మెన్ బై సర్చింగ్. ఓకే, ఇట్ ఈస్ ద ప్రాసెస్ ఆఫ్ సర్చింగ్ ఫర్ ఎన్ ఎలిమెంట్ ఆర్ ఫైండింగ్ ఎన్ ఎలిమెంట్ ఇన్ లిస్ట్ ఐటమ్. ఓకే, ఇన్ list item. Okay, in a list item we are finding for an element, we are finding an element. Okay, we are finding an element or we are searching for an element in a list item. So what a list will be consisting of? List will be consisting of multiple values. Okay, a list will be consisting of more than one element. ఒక లిస్ట్ లో మనకి మోర్ దెన్ వన్ ఎలిమెంట్ అనేది ఉంటుంది అనమాట. సో ఆ మోర్ దెన్ వన్ ఎలిమెంట్ లిస్ట్ లోని ఒక ఎలిమెంట్ ని మనం సెర్చ్ చేస్తున్నాం అనమాట. సెర్చ్ గాని ఫైండ్ చేస్తున్నాం. So at what position the element is present, at what position the element is present, we are searching for the particular element in the list item. Okay, that is when we are searching. And coming to sorting is, the definition of the sorting is we are arranging a particular list of elements in a sequential order. అంటే ఒక సీక్వెన్స్ లో అరేంజ్ చేస్తున్నాం అన్నమాట ఎలిమెంట్స్ ని. సో ఇట్ ఈస్ ద ప్రాసెస్ ఆఫ్ arranging the elements in a sequential order. So it is the process of arranging the elements in a list item in a sequential order. అంటే మన దగ్గర ఉన్న లిస్ట్ ఆఫ్ ఐటమ్స్ ని ఒక ఆర్డర్ లో అరేంజ్ చేస్తున్నాం, ఒక సీక్వెన్షియల్ ఆర్డర్ లో అరేంజ్ చేస్తున్నాం అన్నమాట. దట్ ఈస్ మెన్ బై సార్టింగ్. ఓకే, sequential order. And searching means it is the process of searching for an element or finding an element in a list item. Okay, so it is one important point. So that is the advantage, that is the use of the data structure. So using data structure we can perform two operations. In our data structure concept we can perform two operations. Okay, searching and sorting. So searching means it is a process of searching for an element or finding an element in a list item, and sorting means it is a process of arranging the elements in a sequential order. Okay, that is the use. Okay, now coming to the types of data structure, we are having two types: primitive data structure and non-primitive data structure. Okay, so in this primitive data structure we are storing only one value. Okay, we are storing only one value, whereas in non-primitive data structure we are storing multiple values, that is more than one value at a time. In a list item we are storing more than one value at a time. Okay, that is non-primitive data structure. Okay, so coming to the types of primitive data structure, again the primitive data structure is divided into 5 types. Okay, again the primitive data structure is divided into 5 types. Okay, so what are they are? First one is int, float, char, double pointer. So we already discussed about these points. Okay, when we are talking about the data types concept, where we have talked about these 5 points: int, float, char, double pointer. So what type of values an integer will store? An integer will store an integer value, and a float will store a floating point value, and carry will store a character value, and a double will store a double value, and pointer will store the address of the next node. Okay. So what is an integer will store? An int will be storing an integer value. Stores integer value. Stores an integer value. Whereas for float stores a point value, decimal value. Okay. Decimal value. Okay. And for char means it stores a character value. Item inside the variable will be a character value. Okay. And inside a double it stores a double value. This is also decimal value. Okay. Okay, which will consisting of pointing values. Okay, double value will store a decimal value. Okay, the list item. Okay, coming to the pointer will be stored in the address of the next variable. So it stores the address of next variable. Okay, next variable. So integer stores an integer value, and float stores a floating point value, that is decimal. Okay, it will be storing a decimal value, and char will be storing a character value, and double will be storing a double value, and pointer will be storing a address of next variable. So for each data type there will be a range present. Okay, so for all these data types the range is different. Okay, so for int there will be different range, for float there will be different range, for character there will be different range, for double there will be different range, and for pointer there will be different range. Okay, so we are having different range of values, that is we are having 5 types of primitive data types. Okay, so what are there? First one is int, second one is float, third one is char, fourth one is double, and fifth one is pointer. Okay, so we are having 5 types of data types. Okay, we are having 5 types of primitive data types. Okay, first one is int, second one is float, third one is char, fourth one is double, and fifth one is pointer. Okay, so we already talked about this concept, that is when we are talking about the data types concept we have talked about this. Okay, so we will be coming here. So primitive data types. Now coming to, we'll be going to non-primitive data types. Okay, so these are the primitive data types we are having here. 5 types of primitive data types we are having. So first one is int, second one is float, third one is char, fourth one is double, and fifth one is pointer. Okay, we are having 5 types of primitive data types. And coming to, we'll be shifting to non-primitive data structure. Non-primitive data structure. So sorry, it is primitive data structure, not types. It is primitive data structure. We will be shifting to non-primitive data structure. So what is a non-primitive data structure? So in this data structure, it is a type of data structure we'll be storing multiple values at a time. So in non-primitive data structure, it is a type of data structure where we will be storing multiple values. So in list item, we will be storing more than one value at a time. Okay, more than one value at a time. That is one way non-primitive data structure. Okay. So these non-primitive data structures are divided into two types. These non-primitive data structures are divided into two types. Okay, first one is linear data structure, and second one is non-linear data structure. Okay, first type of non-primitive data structure is linear data structure, and second type of non-primitive data structure is non-linear data structure. Okay, non-linear data structure. So linear data structure, another name for the linear data structure is sequential data structure. Another name for the linear data structure is sequential data structure, and another name for the non-linear data structure is random data structure. Okay, that is one important point. So linear data, coming to the linear data, the first type of non-primitive data structure is linear data structure. Linear data structure. So in linear data structure we are having 4 types. In linear data structure we are having 4 types. Okay, so what are they are? First one is arrays, second one is lists, third one is stack, and fourth one is queues. So a linear data structure is divided into 4 types. Okay, linear data structure is divided into 4 types. So what are they are? First one is arrays, second one is lists, third one is stack, and fourth one is queues. Okay, so arrays, we already do arrays, list, stack, and queues. Okay, linear data structure is divided into 4 types. A linear data structure is divided into 4 types. First one is arrays. Second one is lists. Third one is stacks, and fourth one is queues. Okay. So that is the linear data structure. So we already talked about the arrays. We already talked about the arrays. So what is an array in our C programming? An array is nothing but it is a list of elements. It is a list of elements which are having a common data type of elements. A list of data types of unique data type. So an array is nothing but it is a list of elements where the elements are of single data type. Any one data type of elements are stored in an array. Okay, in an array. In an array. Okay. So an array is nothing but it is a list of elements which are stored of any one common data type. Okay. Any one common data type of elements are present in an array. And coming to the second one is lists. So what is a list? List is nothing but it's a collection of elements. Okay. List is nothing but it is a collection of elements. Okay. So we'll be storing more than one value at a time. Okay. In a list, we'll be storing more than one value. So for this, what we'll be doing is we'll be calling this list as a linked list. Okay. So in our data structure concept, we'll be calling this list as a linked list. Okay. So note the point. Data structure. Data structure concept. Now data structure. A list can be called as a linked list. Okay. Data structure concept. The list can be called as a linked list. Okay. So what is a linked list? A linked list is nothing but it is a collection of nodes. It is a collection of nodes. Okay. A linked list is nothing but a collection of nodes. Node will be pointing to the next node. Okay. Each node will be pointing to the next node. A linked list is nothing but it is a collection of nodes. Okay. Linked list is nothing but it is a collection of nodes where each node will be pointing to the next node. Okay. Each node will be pointing to the next node. And each node, so what a node will be consisting of? A node will be consisting of two fields. A node will be consisting of two fields. What are they? Data field and address field. Okay. Data field and address fields. Okay. 1 second. I'll be going to that nodes. Okay. So linked list is nothing but it is a collection of nodes. Okay, linked list can be defined as a collection of nodes. So what a node will be consisting of? Node will be consisting of two fields. Okay, one is data field and second one is address field. So what is meant by data field? Data field is nothing but if we want to store a value, then we can store the value in the data field. Okay, so directly in the memory location. So where the value will be going directly into the memory location, that is called as the data field. Okay, in data field we'll be storing the actual value. Okay, we'll be storing the actual value, and coming to the address field we'll be storing the address of the next node. Okay, so an address field is nothing but it is the second field in the node. It is second field in the node. In the linked list node we'll be storing the address of the next node. Okay, in address we'll be storing the address of the next node. Okay, and in linked list another important point is in linked list the memory will be allocated by using dynamic memory allocation. The memory will be allocated by using the malloc keyword. Okay, in linked list we will be allocating the memory by using the malloc keyword. That is, we are performing dynamic memory allocation. Okay, for a linked list we are performing dynamic memory allocation. That is, by using the malloc keyword we can allocate the memory. So generally we will be using the new keyword for allocating the memory. No? In the same way, అంటే మన లింక్డ్ లిస్ట్లో మనం malloc కీవర్డ్ యూస్ చేసి మెమరీని అలొకేట్ చేస్తాం మేము. అంటే జనరల్గా అన్ని ప్రోగ్రామింగ్ లాంగ్వేజెస్లో న్యూ కీవర్డ్ యూస్ చేసి మెమరీ అలొకేట్ చేస్తామన్నమాట. కానీ డేటా స్ట్రక్చర్ కాన్సెప్ట్ ఎలాగంటే లింక్డ్ లిస్ట్లోని మనం malloc కీవర్డ్ యూస్ చేసి మెమరీ అనేది అలొకేట్ చేస్తాం అన్నమాట. ఓకే, సో ఇన్ అవర్ లింక్డ్ లిస్ట్ విల్ బి యూజింగ్ ద డైనమిక్ మెమరీ. అంటే malloc కీవర్డ్ అనేది యూస్ చేసి మనం మెమరీ అనేది అలొకేట్ చేస్తాం అన్నమాట. ఓకే, and also for creating a node. Okay, in our data structure, in our linked list concept, we can create for every node there will be structure present. Okay, for every node there will be a structure present. So using a structure we can create a node in our linked list. Okay, మన linked list లోని ప్రోగ్రామింగ్ ఇన్ ద ప్రోగ్రామింగ్ లాంగ్వేజ్ టెర్మినాలజీ నోడ్ ఎలా క్రియేట్ చేస్తామంటే ఒక స్ట్రక్చర్ యూజ్ చేసి నోడ్ని క్రియేట్ చేస్తామంట. సో నోడ్ కెన్ బి క్రియేటెడ్ బై యూజింగ్ అ స్ట్రక్చర్. So what is the syntax is we should be using the keyword called struct. Okay, struct space tag name and open braces and close braces we should declare the fields. We should declare the parameters. Okay, So what are the parameters we should have? Data and address. So a node will be consisting of two fields, data field, address. No. So we'll pass data and address. So how will we declaring the parameters are? So I will take a character parameter, character data type. Okay, char star data. Star is nothing but the pointer variable. Okay, star is nothing but the pointer variable. Char star data and char star address. Okay, so I'm declaring the data parameter and I'm declaring the address parameter, and then I'm pointing to the next node. Okay, so by taking a struct node star next, I'm declaring a pointer variable. Okay, I'm declaring a pointer variable. So I'm pointing the first node to the next node. Okay, I'm pointing the first node to the next node. So I'm taking a third parameter called struct node star next. Struct node star next. Okay, struct node star next. So I'm taking a third parameter called struct node star next, and then I'm closing the brace. So in this way, we can declare a node in our linked list. In our C programming, we can write in a programming terminology, in a programming way, we can write for creating a node. I will be using a structured data type. Okay, so I will be using a structured data type. Okay, struct node, open brace and close braces. So here node is called as a tag name. Okay, node is called as the tag name. So char star data, char star address, and struct node star next hash new. Okay, so that is one important point. That is one important point. So this is called as a linked list. Okay, so linked list will be is a collection of nodes. Okay, linked list is a collection of nodes. And a linked list, what are the advantages of the linked list? So using linked list, we can perform different operations. Okay, we can perform different operations. So what are the operations we can perform are, we can insert a new element at the end of the list. We can insert a new element at the beginning of the list. Okay, we can add an element. We can insert an element at the beginning of the list, and we can delete an element at the beginning of the list. We can delete an element at the beginning of the list, and we can display the complete list. Okay, so in the list we can display the complete list. We can display all the items. We can view all the items. We can view all the elements of a list. And coming to search is, we can search for an element by using the key. So by using the key parameter, we can search for an element. Okay, so basically మనం key యూజ్ చేసే ఒక ఎలిమెంట్ ని సెర్చ్ చేస్తామట మన లిస్ట్ ఐటమ్. సో ఇన్ సేమ్ వే హియర్ ఆల్సో we will be searching for an element by using the key. Okay, we will be searching for an element by using the key. And next one is delete. Deletes an element by using the key. So these are the advantages of the linked list. So we can perform 5 different operations in linked list. What are they? Insertion, deletion, display, search, and delete. Okay, we can insert an element at the beginning of the list. We can delete an element at the beginning of the list. We can display the complete list. We can search for an element by using the key, and we can delete an item by using the key. So these are the advantages of the linked list. Okay, and coming to the types of linked list. Okay, coming to the types of linked list. So coming to the, so linked list is mainly divided into 3 types, ma'am. Okay, a linked list is mainly divided into 3 types. Okay, they are, first one is single linked list, third one is double, so second one is double linked list, and third one is circular linked list. So we're having 3 types of linked list which is divided. So linked list is mainly divided into 3 types. First, what are they are? First one is single linked list, second one is double linked list, and third one is circular linked list. Okay, so these are the 3 types of linked list. Okay, so let us discuss about each type of linked list. Okay, let us discuss about each type of linked list. So in a single linked list, what we are having is, it is a linked list. So the definition, the actual definition of the single linked list is, it is a linked list which is having a node where each node has one data field and one address field. Okay, so it is a linked list which is having a node. Okay, which will be having one node where, which will be having a collection of nodes. Okay, it is a linked list where each node will be having one data field and only one address field. Okay, సో ప్రతి సింగిల్ లింక్డ్ లిస్ట్లో ప్రతి నోడ్కి ఎలా ఉంటుందంటే ఓన్లీ వన్ డేటా ఫీల్డ్ ఉంటుంది అండ్ వన్ అడ్రస్ ఫీల్డ్ మాత్రమే ఉంటుంది అనమాట. మోర్ దెన్ వన్ ఉండవన్నమాట. ఓన్లీ వన్ డేటా ఫీల్డ్ అండ్ ఓన్లీ వన్ అడ్రస్ ఫీల్డ్ మాత్రమే ఉంటుంది అనమాట. సో సింగిల్ లింక్డ్ లిస్ట్ is a linked list in which each node will be having only one data field and only one address field. Okay, and each node will be, and in a single linked list each node will point to the next node. Okay, in each node will point to the next node, and in a single linked list for each element there will be node present. For each element there will be node present, and each node will be having two fields. Okay, data field and address field. Okay, so data field is nothing but it will be consisting of the actual value, and address field is nothing but it consists of the address of the next node. Okay, and in a single list we are having the first node is called as the head. Okay, and in a single list what we are saying is, we will be saying one head. We are having one element called head. So what is the head is, we are having the first node. The first node in the single linked list can be said as the head, and the last node is called as tail. Okay, so the condition of the single linked list is, if the list became full. Okay, if the list became full, then we'll say that head is 1, and if the list is empty, we'll say that the head is -1. Okay, so the condition in the single linked list is, if the list is full, then we'll say that head is equal to 1, and if the list is empty, we'll say that the head is equal to -1. Okay. Okay. So for example, let us take an example. Okay, let us take an example where a single linked list is having 3 nodes. Okay, single linked list is having 3 nodes. So I'll explain it. I'll explain it. Okay, 1 second. So I'll be taking one. I will be taking 3 nodes. Okay, I will be taking 3 elements. I will be taking 3 elements. So it is a single linked list. Okay, in a single linked list, I will be taking 3 elements. Okay, I will be taking 3 elements. Okay, I will be taking 3 elements where each element is having one node. Okay, where each element is having one node. Okay, so these are the 3 elements we are having. So how many nodes we are having? 3 nodes. We are having 3 nodes. So each element is called as a node. In our single linked list, each node is called as a node. Each element is called as a node, and there will be connection between this each node. Okay, there will be link present. There will be link present between each node. Okay, there will be link present between each node. Okay, there will be a link present between each node. Okay. So each node will be having 2 fields. Each node will be having 2 fields. Okay. Each node will be having 2 fields, a data field and address field. Okay, a data field and address field. So this is called as, first field is called as data field, and second field is called as the address field. Okay. First field is called as data field, and second field is called as, first field is, and second field is called as, okay, data field and address field. So this is what I'm explaining in the last class. No, at this time only I went somewhere. Okay. So we are having 2 fields for each node. Okay. So each element in the single linked list is called as a node. Okay. Each element in a single linked list is called as a node. So each node will be having 2 fields, as we already know that each node will be having 2 fields. Okay. One data field and second one is address field. Okay. One is data field and second one is address field. Okay. So let us store some elements. Let's just store some elements in each element. So I will be storing 1 here. In the first element, in the first node, I am storing the data field as 1, and the second element as 2, and third element is 3. Okay. So I am storing 1 for the first element, second 2 for the second element, and 3 for the third element. Now I will be storing the address. I will be storing the address. Okay. So here the address of the first node is 1000. Okay. So for the first value, I am storing the address as 1000. Okay, I am storing the address as 1000. So in the address field, I am storing the value called 1000. Okay, in the address field, I am చేస్తున్నానంటే 1000 అనే value store చేస్తున్నాను నేను. So in the same way for the second node also, I will be storing the address called 2000. 2000. Okay, and for the third field, I will be storing the address called 3000. So what we have said, in the data field, in a linked list, in the data field, we will be storing the actual value, and in address, I will be storing the address of the next node. So second node యొక్క అడ్రస్ నేను ఫస్ట్ నోడ్ లో స్టోర్ చేస్తాను అనమాట. సో ఇక్కడ సెకండ్ నోడ్ యొక్క అడ్రస్ ఎంత 2000. సెకండ్ నోడ్ యొక్క అడ్రస్ ఎంత 2000. ద అడ్రస్ ఆఫ్ ద సెకండ్ నోడ్ ఇస్ 2000. సో ఐ విల్ బి స్టోరింగ్ దిస్ 2000 ఇన్ ద ఫస్ట్ ఎలిమెంట్స్ అడ్రస్ ఫీల్డ్. ఓకే. సో ఇక్కడ 2000 కాస్త నేను ఇక్కడ స్టోర్ చేస్తాను అనమాట. సో ఐ విల్ బి స్టోరింగ్ హియర్. And in 2000 the address field, I will be storing 3000. Okay, I will be storing 3000. So address of the next node. Okay, so 3000 అనేది address of the third node now. So second node యొక్క address లో నేను 3000 third node యొక్క address ని స్టోర్ చేస్తాను అన్నమాట 3000. Okay, and coming to the third address, I will be storing null. So called as the end of the list. Okay, this is called as the లాస్ట్ మనం నల్ క్యారెక్టర్ స్టోర్ చేస్తున్నాము దాన్ని ఎండ్ ఆఫ్ లిస్ట్ అంటామన్నమాట. సో దిస్ ఇస్ ద ప్రాసెస్ ఆఫ్ స్టోరింగ్ ద వాల్యూస్. ఓకే. సో ఫర్ ఎగ్జాంపుల్ ఐ టేకెన్ 3 elements where each element will be consisting of a node. Okay, where each in our linked list we will be storing 3 elements where each element will be having one node. Okay, so what a node will be consisting of, each node will be having 2 fields. One is data field and second one is address field. Okay, so I'm storing data field as 1 for the first node, I'm storing the address. I'm storing the data feed for the first element as 1, and I'm storing data feed for the second element as 2, and I'm storing data feed for the third element is called 3, and I'm storing the address values also. The address value for the first node is 1000, and the address value for the second node is 2000, and the address value for the third field is called as 3000. Okay, so I'm storing the address. So, and again another important point is, in the address we'll be storing the address of the next node. Okay, అంటే ఫస్ట్ నోడ్ లోని సెకండ్ నోడ్ యొక్క అడ్రస్ ని స్టోర్ చేస్తాను అనమాట. అలాగే సెకండ్ నోడ్ లోని థర్డ్ నోడ్ యొక్క అడ్రస్ ని స్టోర్ చేస్తాను అనమాట. ఓకే, సో ఇన్ ద ఫస్ట్ నోడ్ ఐ విల్ బి స్టోరింగ్ ద అడ్రస్ ఆఫ్ ద సెకండ్ నోడ్, అండ్ ఇన్ సెకండ్ నోడ్ ఐ విల్ బి స్టోరింగ్ ద అడ్రస్ ఆఫ్ ద థర్డ్ నోడ్. సో ఇక్కడ ఫస్ట్ నోడ్ యొక్క అడ్రస్ ఎంత 1000. సో 1000 అలా ఉంచేసి సెకండ్ నోడ్ యొక్క అడ్రస్ ఎంత 2000. సో ఫస్ట్ నోడ్ యొక్క అడ్రస్ లో నేను 2000 ని స్టోర్ చేస్తాను అనమాట. అడ్రస్ ఆఫ్ సెకండ్ నోడ్. ఓకే, ఫస్ట్ అడ్రస్ లోని అడ్రస్ ఆఫ్ సెకండ్ నోడ్ ని స్టోర్ చేస్తాను. 2000 ని నేను ఫస్ట్ అడ్రస్ స్టోర్ చేస్తాను. అలాగే నోడ్ యొక్క అడ్రస్ ఎంత 3000 కదా. సో 3000 ని నేను సెకండ్ నోడ్ యొక్క అడ్రస్ లో స్టోర్ చేస్తాను అనమాట. సో by doing this, what will happen is I'm creating a single linked list. Okay, I'm creating a single linked list. So single list will be having only two fields for every node. For every element there will be two fields. That is called data field and address field. Okay, only one data field ఉంటుంది, అలాగే only one address field మాత్రమే ఉంటుంది అన్నమాట. Okay, so that is one important point. I am creating a linked list where each node will be consisting of one node, where each node will be consisting of two fields, data field and address field. And data field is consisting of the actual value, and address field is consisting of the address of the next node. Okay, address field is consisting of the address of the next node. And last null character is called as the end of the list. Okay, and last null character is called as the end of the list. Okay, so I'm creating a linked list. And another important point is, the first node is in our single linked list. In our linked list, the first node is called as the head. Okay, the first node is called as the head. The first node in our linked list is called as the head element. Head element. The first node is called as the head element, and second node is called as the, and the last node is called as the tail element. As the tail element. Okay, so please follow these steps. Okay, so initially I am taking three nodes where each data feed is consisting of 1, 2, 3, and I'm storing the address of the next node. Okay, 2000 in the first node's address and 3000 in the second node's address, and null is called as the end of the list. Okay, and I'm creating a linked list where another important point is, for every linked list there will be one head and one tail. Okay, that is an important point. Okay, that is one important point. So for every linked list, so I write this important point. For every linked list, there will be one head and one. For every linked list, for every linked list, there will be one head and one tail. There will be one head and one tail. Okay, there will be one head and one tail. So one head, one tail మాత్రం ఉంటుందన్నమాట. Okay, this is what I'm explaining in the last class. No, last class in ఈ కాన్సెప్ట్ ఎక్స్ప్లెయిన్ చేస్తున్నాను, డయాగ్రామాటిక్గా ఎక్స్ప్లెయిన్ చేస్తున్నాను. ఓకే, so I'm creating a linked list where each node is having two fields. Okay, one data field and one address field. So the data field is consisting of the actual value, and the address field is consisting of the address of the next node. Okay, address field is consisting of the address of the next node. Okay, and each node is pointing to the next node. In our linked list, in our single linked list, each node is pointing to the next node. Okay, so I'm establishing a link. I'm keeping a link between each node. Okay, so we can see the one arrow. We can see the arrow here. I'm creating a link between two nodes. So arrow is nothing but it indicates that a link is present between each two nodes. Okay, link is present between each two nodes. So link అనేది ఉంటుందన్నమాట. Link will be present between each two nodes. Okay, that is one important point. So let us go to so coming to the syntax. Coming to the syntax. Okay, coming to the syntax. Coming to the syntax of a single linked list. So single linked list basically is created by using a structure. Okay, single linked list is created by using basically a structure. Okay, so we already discussed about the program. No, we already discussed about the program. No, so again I will take the program. So let me take out the program. Let me take out the program. So I'll go to file, open, single linked list. Okay, here. So I'm taking a node. Okay, I'm taking a node which is having two parameters. Okay, so I'm taking a structure to create a node. Okay, so I will be writing the syntax called struct node, open braces and close braces. I'm taking the number as a parameter. Okay, I'm taking the number as a parameter int num, and then I'm taking the next pointer called struct node star next pointer. Okay, and then I'm declaring the methods. Firstly, we are having a main function. So in main function, I'm declaring, and I'm asking the user to enter the number of nodes. So printf input the number of nodes, scanner percent ampersand of n, and then I'm calling the method called create node list. Okay, and then printf I'm printing the statement called data entered in the list, and I'm calling the display list. So create node list and display list are the two methods we're having in this program. Okay, so firstly, I'm declaring a method called void create node list. Okay, so in this create node list, I'm having two parameters. Okay, struct node star fn node and star tmp. So one is for inserting the values and one is for storing the temporary value. Okay, and then I'm having two parameters int num and I. I'm declaring two parameters, and then so here we can see malloc keyword I'm using. Here I'm using the malloc keyword. So జనరల్గా మనం ఎవ్రీ ప్రోగ్రామింగ్ లాంగ్వేజ్ మనం ఏం చేస్తామంటే విల్ యూజింగ్ ద న్యూ కీవర్డ్. ఓకే, మెమరీ అలొకేట్ చేయడానికి న్యూ కీవర్డ్ యూజ్ చేస్తామన్నమాట. బట్ ఇక్కడ డేటా స్ట్రక్చర్ నేను లింక్డ్ లిస్ట్లో ఏం చేస్తున్నానంటే మ్యాలెక్ కీవర్డ్ యూజ్ చేసి మెమరీని అలొకేట్ చేస్తున్నాను అనమాట. సో ఈ మ్యాలెక్ కీవర్డ్కి ఇటువైపు సో దిస్ సైడ్ అండ్ దట్ సైడ్ దేర్ విల్ బి టూ పారామీటర్స్. ఓకే, ఫర్ దిస్ మ్యాలెక్ కీవర్డ్ దేర్ విల్ బి టూ పారామీటర్స్. వన్ ఈస్ కాల్డ్ as the struct node star, and second one is how much size I want to allocate. So size of function will be used for allocating the size. So for passing the size, I will be in the malloc function. I will be using the size of function. Okay, size of struct node. So here the size will be passed here. The size value will be passed in this place of the struct node. Okay. So then I am checking for the condition if st node. So here what st node will be consisting of? St node will be consisting of the size. So memory allocated. Okay, so struct st node if st node is equal to null. So I'm checking for the null condition. Okay, if st node double is equal to null, then printf memory cannot be allocated. So I'm printing the statement that memory cannot be allocated. Why? Because I'm checking for the condition called null. So null means there is nothing in the variable. No, there is nothing in the variable. Null అంటే ఏంటంటే బేసిక్గా అందులో ఏమీ లేదు అని అర్థం. సో అందుకని నేను printf ఏం చేస్తున్నానంటే memory cannot be allocated అని స్టేట్మెంట్ ప్రింట్ చేస్తున్నాను అనమాట. Or else I will be writing the logic. So printf input data for node 1, scanf percent ampersand of num, st node pointing to num is equal to num, and st node pointing to next ptr is equal to null. So tmp is equal to st node. Okay, I'm storing the value of st node in the tmp. So what is this logic is for? This logic is for reading the data for the node through keyboard. Okay, so reading data for the node using keyboard. Okay, using keyboard and passing some input values for this program. Okay, so next is the actual program. So creating a node and adding to linked list. Okay, actually program is creating n nodes and adding to linked list. Okay, so I'm taking a for loop. Okay, so for iterating for n number of times, I'm taking a for loop. Okay, for I is equal to 2. Firstly, I'm initializing the value that is I is equal to 2, and next I'm passing the condition. I less than equal to n. Okay, I less than equal to n, I plus plus, I less than equal to n, I plus plus, and fn node is equal to struct node star malloc. So I'm using the malloc keyword for allocating the memory. Okay, I'm using the malloc keyword for allocating the memory. Struct node star malloc size of struct node, and if fn node is equal to null, again I'm checking for the null condition. Okay, again I'm checking for the null condition. So again I'm checking for the null condition. So if fn node is equal to null, so I'm checking for the null parameter. Okay, so I'm printing the statement as if fn node is equal to null, then open brace printf memory cannot be allocated. Okay, memory cannot be allocated. So if it is equal to null, if fn node is equal to null, so if the memory is null, if nothing is there in the fn node variable, then I'm printing the statement called memory cannot be allocated. Or else if a value is there, then I will write the program. So printf input data for node star percent d comma I, scanf percent d ampersand of n. So fn node points to num is equal to num, and fn node points to next ptr is equal to null. So links the num field of fn node with the links the address field of fn node. So this is the first function, and second function is display list. Okay, display list. So in this display list, what I'm doing is I'm declaring a pointer variable. I'm declaring a pointer variable. So I'm checking for the condition that if st node double is equal to null, okay, if st node double is equal to null, then printf list is empty. Then printf list is empty, okay. So else tmp is equal to st node while tmp not is equal to null. So I'm checking for whether tmp is not is equal to null or not. So what is st node here? St node is nothing but what is st node? St node is nothing but it's nothing but malloc keyword. We are allocating the memory, that is called st node. Okay. So if st node double is equal to null, printf list is empty, or else I will write the logic. So actual program I will be writing. So tmp is equal to st node, while tmp not is equal to null. So I'm checking for whether it is not is equal to null or not. Then I will be printing the value. Data is percentage slash and temp pointing to null, and temp is equal to next ptr. So this is the program. Okay. This is the program. Okay. There are some errors in this program, okay? No, there are no errors. Run the program will be executed. So input the number of nodes, okay? So input the number of nodes. So 5. Data for node 1, 5. Again, I will run the program. See, data entered in the list is I'm taking the data. I'm getting the data. Okay, data. So we entered the values called 1 2 3 4 5. So entered data is 1, entered second pair data is 2, and entered second data is 3, and entered second data is 4, and entered second data is 5. So I'm displaying the number of elements. Okay, I'm displaying the actual data of the elements. Okay, I've already posted this program now. I will post this program, okay, in the Skype, in the Brew group. I will be posting the program. 1 second. I already posted కదా. I will be posting this program. Already post చేసినట్టు ప్రోగ్రామ్ ఓకే ఓకే క్లాస్ అయిపోయి పోస్ట్ చేస్తాను నేను సింగిల్ లింక్ లిస్ట్ అవుట్పుట్ వస్తుంది పోస్టింగ్ గ్రూప్ program. Okay, already single link list. Already single link program is there. Already attach చేసినట్టున్నాను కదా already. Because single link list program attach చేశాను actually. Okay, so that is the program. So I already attached the program. Okay, you can check out in the previous programs. So that is meant by single linked list. Okay, coming to the double linked list. Coming to the చెప్పండి
ఈ కాన్సెప్ట్ లో చెప్పినట్టున్నారు కదా నేను
అదే డయాగ్రామ్ కింద ఆగిపోయింది కదా మ్యామ్ డయాగ్రామ్ దగ్గర ఆగిపోయింది కదా మ్యామ్ క్లాస్ డయాగ్రామ్ చెప్పినప్పుడు నాకు వేరే ఫోన్ రావటం వల్ల నేను వెళ్ళాను కదా సో అదే కంటిన్యూ చేస్తున్నాను డయాగ్రామ్ చెప్పాను కదా ఈ డయాగ్రామ్ ఇదిగోండి ఈ డయాగ్రామ్ దగ్గర ఆగిపోయింది కదా లాస్ట్ టైం క్లాస్ సో దీన్నే కంటిన్యూ చేస్తున్నాను నేను ఎగ్జిక్యూట్ చేశాను అందుకే ప్రోగ్రామ్ని ఎగ్జిక్యూట్ చేశాను అందుకని ఓకే 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 So coming to the next type of linked list called as double linked list. Okay, coming to the next type of linked list called as double linked list. So in double linked list, what we'll be having is it is a type of linked list where we'll be having 3 fields in each node. Okay, in each there will be 3 fields. What are the 3 fields we are having? We are having 2 address fields and 1 data field. Okay, in the double linked list, we'll be having 3 fields for each node. So it is a collection of nodes where each node will be having 3 fields. So each node is having 3 fields. What are there? There are 2 address fields and 1 data field. So first address field is pointing to the previous node, and second address field is pointing to the second node, afterwards node, before node and afterwards node. Okay. So I will draw the diagram. So ఇది అర్థమైంది కదా దరెస్ట్ చేస్తున్నాను అర్థమైంది కదా సో ఇలా ఎక్స్ప్లెయిన్ double linked list. Okay, I'll explain about double linked list. So I will take 3 nodes. Okay, I will take 3 nodes here. I will take 3 nodes here. I will take 3 nodes here. So there will be 3 fields in each node. Okay, there will be 3 fields in each node. There will be 3 fields in each node. Okay. There will be 3 fields for each node. There will be 3 fields for each node. So one is data field, one is data field, and these both are address fields. Okay, these both are address fields. So one is data, and ఇటువైపు అటువైపు ఏమున్నాయంటే అడ్రస్ ఫీల్డ్స్ ఉంటాయి మేము డేటాకి ఇటువైపు నెక్స్ట్ డేటాకి ఇటువైపు కూడా అడ్రస్ ఫీల్డ్ ఉంటుంది. ఓకే, data field. I stopped at this in the last class. Okay. So let us store some elements. Okay, let us store some elements in this diagram. So first of all, I will be creating a link. Okay, I will be creating a link. I will create a link between each node. I will be creating a link between each node. I will be creating a link between each node. So let us store some elements. Let us store some elements in each node. Okay. So I will be storing like here 1. Here 1, 3. 1, 2, 3. So I will be taking here and here also and here and here. So each node will be having one head node, one head element, and the last element is called as a tail element. So basically, so what is happen is, so here I'm taking 3 elements. Okay, I'm taking 3 nodes in which each node will be having data value, actual data value. Each node is having one actual data value. So for the first node, I'm placing the 1 as the actual data value, and for the second node, I'm placing the 2 as the actual data value, and for the third element, I'm placing the 3 as the actual value, actual data value. Okay. So for now, so what will be the address? What will be the address? Okay, what will be the address is, we are placing the address that is called as the previous. So one address field is called as the address for the previous node, and the second address is called as address for the next node. Okay. So here the first node will be having null value. Okay, null value, because there is no previous node. Okay, but for the second node, I will placing a 2000. Same concept. Address of the next node. Okay. Here again 1000 will come, address of the previous node, and here 3000 will come, and again here 2000. Okay, it will be null. It will be here it will be null. So in this way, so every first address field will be consisting of the previous address of the previous node, and every second address field will be have consisting of the address of the second node. Okay, so that's why I'm taking the first address field in the first node. I'm taking the first address as the null field, and second field and the second address field I'm taking the 2000. Okay, 2000 is nothing but 2000 is the address of the second node. Okay, so here we can see, here we can see here. Here 2000 is present. No, this 2000 I'm placing that in the first node. Okay, in the first node address I'm placing the 2000 as address, and in the second node also there are two addresses. One address is for storing the node address of the first node, that is 1000, and second address is for storing the address for the third node. Okay, so 3000 I'm storing. So 2000 in the first node I'm saving, and 3000 in the second node I'm saving, and again the first node in the first address in the third node, we will be having the address of the previous node, that is 2000, and the address of the second node is null character, that is end of the list. Okay, we'll be saying that the last null value is called as the end of the list. Okay, end of the list. So here also I'm storing three values. Okay, 1, 2 and 3. So here I'm taking three nodes where each node is having one data field and two address fields. Okay, and each node will be having, each linked list will be having one head element and one tail element. Okay, one tail element. Okay, let us take my program. Let us take the program. Okay, we'll execute the program. Double linked list. Okay, double linked list की program type चलेगा. Double linked list, I will explain the program afterwards. Okay, I'll explain let us go to the next concept. Okay, let us go to the next concept. So next concept is, so what is the next type of data structure we are having? The next type of data structure we are having is linear data structure, that is non-primitive data structure, that is linear non-linear data structure. Linear data structure, the next type of data structure is stacks. The next type of data structure is stacks. Okay, so coming to, so before going to the stacks concept, so let us discuss what is meant by stack. Okay, so stack is data structure. Okay, stack is a, let me discuss about the definition of the stack. So stack is nothing but it is data structure. Okay, stack is nothing but it is data structure where a list is stored. Okay, stack is nothing but it is data structure where list of elements are stored. Okay, so stack is data structure. Okay, stack is a kind of data. Stack is kind of a structure where you can store list of elements. Where we can store list of elements, that is multiple elements we can store in a stack. Stack is the kind of data structure where we can store list of elements, అంటే మల్టిపుల్ ఎలిమెంట్స్ అనేది స్టోర్ చేస్తాం మేము స్టాక్లోని, అంటే లిస్ట్ ఆఫ్ ఎలిమెంట్స్ ఉన్నాం కాబట్టి మోర్ దెన్ వన్ ఎలిమెంట్ అనేది స్టోర్ చేస్తాం అన్నమాట. సో ఫర్ ఎగ్జాంపుల్ లెట్ us take an example. So I'm taking a list of elements called, so I'll erase this. Okay, so I'm taking a list. Okay, I'm taking one list. In that I will be placing some 5 to 6 elements. Okay, I will be placing some 5 to 6 elements. Okay, so 1, 2, 3, 4, 5, 6 and 7. So let us take some list of elements that is called as a stack. In that list of elements, I will be storing some multiple values. Okay, I will be storing some multiple values. So let me store some multiple values. Okay, so for example, the first element is, so firstly, so I'll explain the definition. Okay, first of all, I will explain the definition. So stack is nothing but stack is a kind of data structure where you can store list of elements. Okay, list of elements, and each stack will be having one size element. Each stack will be having one index. Okay, each stack will be having one index. So that index will be keeping track of the information. Okay, so each element of the stack will be having an index. Will be having one. The so each element in the stack will have an index. So this stack, this index will be keeping some track. Okay, this index will keep the track, will be keeping the track of the stack. Okay, this index will be track of the elements. in the stack. Okay, will be storing. So this index will be keeping track of the elements in the stack. Okay, and also every element will be inserted and deleted at only one end. Okay, in the stack lo em avutundante, in stack every element is inserted and deleted at only one end. Okay, that is called as the top of the element. Okay, so in stack, so in our stack, every element is deleted one end. Okay, every element will be inserted and deleted at only one end. That one end of the stack is called as the head of the list. Okay, that one end in our list is called as the head of the list. Okay, and every stack will be having two operations. Okay, every stack will be having two operations. So what are they? And another important point is the stack will be working in the basis of last in first out basis. Okay, stack will be operated in the form of last first out or basis. Okay, so stack will be important point. Stack will be operated in the form of last in first out basis. Last in first out. Okay, leaf of full form. So what is the leaf? Last in first out. Last in first out. Stack will be operated in the form of last in first out basis, and also that one end is called as head of the list. A stack will be operated in the form of list out last in first out basis, and every stack will be having two operations. Okay, every stack will be having two operations. Every stack or list item. In every stack item will be having two operations. Two operations. First one is operation. Second operation is called as pop. Okay, so every stack in our list item will be having two operations. Okay, so stack is a kind of data structure where we can store list of elements, and each element in the stack will be having one index. This index will be keeping track of the elements in the stack. అంటే ఏంటంటే స్టాక్ లో ఇన్సర్ట్ చేసిన ప్రతి ఎలిమెంట్ కూడా ఒక ఇండెక్స్ అనేది ఉంటుంది అనమాట. సో ఇండెక్స్ యూస్ చేశానే కదా మనం తెలుస్తుంది ఏ పొజిషన్ లో ఎలిమెంట్ అనేది ఉంటుందో మనకి అర్థమవుతుంది కదా మ్యామ్. సో దిస్ ఇండెక్స్ విల్ బి కీపింగ్ ట్రాక్ ఆఫ్ ద ఎలిమెంట్స్ ఇన్ ద స్టాక్. దిస్ ఇండెక్స్ విల్ బి కీపింగ్ ట్రాక్ ఆఫ్ ద ఎలిమెంట్స్ ఇన్ ద స్టాక్. సో ఇండెక్స్ యూస్ చేసి మనం ట్రాక్ చేస్తామన్నమాట స్టాక్ లో ఉన్న ఎలిమెంట్స్ అనేసి. సో దిస్ ఇండెక్స్ విల్ బి కీపింగ్ ట్రాక్ ఆఫ్ ద ఎలిమెంట్స్ ఇన్ ద స్టాక్. సో స్టాక్ లో ప్రతి ఎలిమెంట్ కి ట్రాక్ చేయాలంటే ఇండెక్స్ యూస్ చేసి ట్రాక్ చేస్తామన్నమాట, ఏ పొజిషన్ లో ఉంది అనేది చెప్తాం అన్నమాట. సో దిస్ ఇండెక్స్ విల్ బి కీపింగ్ ట్రాక్ ఆఫ్ ద ఎలిమెంట్స్ ఇన్ ద స్టాక్, అండ్ ఇన్ అవర్ స్టాక్ ఎవ్రీ ఎలిమెంట్ విల్ బి ఇన్సర్ట్ అండ్ డిలీటెడ్ ఓన్లీ వన్ ఎండ్. అంటే స్టాక్ లో నేను ఎలిమెంట్ ఇన్సర్ట్ చేయాలన్నా డిలీట్ చేయాలన్నా వన్ ఎండ్ లో మాత్రమే ఆపరేషన్స్ అనేది పర్ఫామ్ చేయగలన్నమాట. ఆ వన్ ఎండ్ ఏమంటామంటే హెడ్ ఆఫ్ ద లిస్ట్ అంటారు అనమాట. అంటే స్టాక్ లో నేను ప్రతి ఎలిమెంట్ ఇన్సర్ట్ చేయాలన్నా డిలీట్ చేయాలన్నా వన్ ఎండ్ లో మాత్రమే ఇన్సర్ట్ చేస్తాను, డిలీట్ చేస్తాను. ఆ వన్ ఎండ్ ఏమంటారంటే హెడ్ ఆఫ్ ద లిస్ట్. దట్ వన్ ఎండ్ ఇన్ అవర్ లిస్ట్ ఇస్ కాల్డ్ యాజ్ ద హెడ్ ఆఫ్ ద లిస్ట్. ఓకే, అండ్ ద స్టాక్ విల్ బి ఆపరేటెడ్ ఇన్ ద ఫార్మ్ ఆఫ్ లిస్ట్ లాస్ట్ ఇన్ ఫస్ట్ అవుట్ బేసిస్. స్టాక్ విల్ బి అంటే స్టాక్ లో ఆపరేషన్స్ ఎలా పర్ఫామ్ చేస్తామంటే లాస్ట్ ఇన్ ఫస్ట్ అవుట్ ఫార్మాట్ లో పర్ఫామ్ చేస్తామంట. అంటే ఏంటంటే ద లాస్ట్ ఇన్సర్టెడ్ ఎలిమెంట్ విల్ బి ద ఫస్ట్ ఎలిమెంట్ విచ్ విల్ బి రిమూవ్డ్ అవుట్. ఓకే, లాస్ట్ న ఎలిమెంట్స్ ఇన్సర్ట్ చేస్తున్నప్పుడు లాస్ట్ ఏ ఎలిమెంట్ అయితే ఇన్సర్ట్ చేసామో ఆ ఎలిమెంట్ ఫస్ట్ డిలీట్ చేస్తాం అన్నమాట. సో లాస్ట్ ఇన్ ఫస్ట్ అవుట్, లాస్ట్ ఇన్సర్ట్ ఎలిమెంట్ విల్ బి ద ఫస్ట్ ఎలిమెంట్ విచ్ విల్ బి రిమూవ్డ్ అవుట్. ఓకే, stack will be operated in the form of last in first out basis, and every stack in our list item will be having two operations. Okay, ప్రతి స్టాక్ కి మన లిస్ట్ ఐటమ్ లో ప్రతి స్టాక్ కి టూ ఆపరేషన్స్ అనే ఉంటాయి అన్నమాట. ఫస్ట్ వన్ ఏంటి అంటే పుష్, సెకండ్ వన్ ఇస్ పాప్. సో వాట్ ఈస్ ద మీనింగ్ ఆఫ్ దిస్ టూ ఆపరేషన్స్? వాట్ ఈస్ ద మీనింగ్ ఆఫ్ దిస్ టూ ఆపరేషన్స్ is the meaning is push operation. The meaning of the push operation is whenever you want to insert an item, in the stack, then we will be calling the push operation. Okay, this is used for this operation is used for this operation is used for inserting element insert element into the stack. The next one is pop. Okay, operation is used for removing an element from the stack. Okay, is user element from the stack. Okay, and each element in the stack is removed in reverse order. Okay, each element in the stack will be removed in the reverse order. Will be operated in the form of reverse order. That is the last and last element. The first element. I will write that point also. On the stack, the operation. The remove operation on the stack is called. The operation stack is called reverse order of the stack. In the reverse order, the elements are inserted. Okay, the elements are inserted. Operation of the stack is called in the reverse order of the elements are inserted. Okay, so we're having two elements. Okay, and also another important point is there are two terms. Already we have said that push operation and pop operation are the two types of operations we are having in the stack. And another important point is index. A stack index will be keeping track of the information of the stack. A stack index will be keeping track of the information of the stack. Stack index will be keeping track of the information of the stack. And another important point is stack is full. Okay, whenever the stack is full of items, then we'll say that the stack is overflow. Okay, that is one point. Okay, so after inserting the elements in the stack, okay, after inserting the elements, that is after inserting elements in the stack, okay. So if the stack is full, okay, if the stack is full, then we'll say that the condition is overflow. Okay, after inserting the elements in the stack, we'll say that if the stack is full, okay, then we'll say that the condition is overflow. After inserting the elements in the stack is full. Okay, then we'll say that the condition is overflow. After inserting the elements in the stack, if the stack is full, okay, అంటే స్టాక్ కంప్లీట్ గా ఫిల్ అయిపోయింది అనుకుందాం మేము. స్టాక్ అనేది కంప్లీట్ గా ఫిల్ అయిపోయింది అనుకున్నాం అనుకోండి, అప్పుడు మనం ఏమంటాం అంటే కండిషన్ ఓవర్ఫ్లో అంటారు అనమాట. అంటే స్టాక్ అనేది ఓవర్ఫ్లో అయిపోయింది అనమాట, అంటే మొత్తం కంప్లీట్ గా ఫిల్ అయిపోయింది అనమాట, అంటే ఇంకో ఎలిమెంట్ ని మనం ఇన్సర్ట్ చేయలేమన్నమాట. దెర్ ఈస్ నో పాసిబిలిటీ ఫర్ ఇన్సర్టింగ్ ద ఎలిమెంట్స్ ఇంటూ ద స్టాక్ ఆఫ్టర్ ద స్టాక్ ఈస్ ఫుల్. ఓకే, so if the stack is full, we'll say that the condition is overflow. So at that time only the top will be 1, the top will be -1, the top will be 1. Yes, the top will become 1. Okay, so after inserting the elements in the stack, if the stack is full, then we'll say that the condition is overflow. And if the stack is empty, okay, so before insert the elements, before we insert the elements, if the stack is empty, then we'll say that the condition is underflow. Okay. So in this case, top is -1. before we insert stack is empty, then we'll say that the condition is overflow. Then the condition is overflow, and before we insert the elements, if the stack is empty, okay, if the stack is empty, then we'll say that the condition is underflow, okay. In that case, the top is -1, okay. The top became -1, okay. The top became -1, and the first inserted element will be going to the down position, okay. The first inserted element will be the last element which will be deleted, and the last inserted element will be the first element which will be deleted, okay. So that point also we can write, okay. So the first inserted element in the stack, okay. If the stack is empty, okay. Inserted element, the first inserted the stack is empty, then we insert the element in the stack. The first inserted element in the stack will be the last element. Okay. Last element which will be pop. Pop operation will be calling, okay. Pop operation will be calling, okay. So the first inserted element in the stack will be the last element which will be popped out, okay. The element in the stack will be the last element which will be popped out, and the last element in the stack will be the first element which will be popped out, okay. So the last inserted element will be the first element which will be popped out. Last inserted element will be in the stack will be the first element which will be popped out. The last element which will be popped out, okay. That is the important point. And coming to the algorithm, okay, so let us see an algorithm. Let us see the algorithm. So algorithm for stack, okay. So initially what we'll do is we'll write an algorithm. We'll write an algorithm for inserting an item into the stack, and we'll write an algorithm for the removing the element from the stack, okay. So initially we'll call the push operation, okay. We'll call the push operation, push of stack comma top comma max stack comma item. So I'm passing four variables, okay. I'm passing four variables. Push off in brackets, in open brackets and close brackets. I'm passing four parameters, okay. That is, first parameter is the stack, second parameter is the top. So what is meant by top? So the top means the last inserted element position. The position at the last inserted item will call that as top, okay. Stack comma top comma max stack comma item. So the top of the element is when we insert an element or delete an element, okay. When we insert an element or delete an element, the top becomes -1, okay. The top becomes -1. So if the stack is full, okay, we'll say that the top is +1, and if the stack is empty, okay, we'll say that the top is equal to -1. So the top is nothing but it is the first element. It is the topmost element. It is the topmost element in the stack. We'll call it as the top, okay. So I'm passing four parameters: stack comma top comma max stack. So max stack comma item, okay. So this procedure pushes an item into a stack, okay. So for push operation, what we should do is, the first step what we should do is we should check whether the stack is full or not, okay. We should check for the stack is already full or not, okay. So for that I will write the condition is if top is equal to max stack. Here I am explaining, okay, in this line here. If stack is max stack, if top is max stack, then print overflow and return, okay. So if the stack is full means, then we'll say that the print is overflow, print the overflow statement and return. Then so if the stack is full, then we'll say that the top is equal to top plus 1, okay. Top is equal to top plus 1. So we'll increase the top by 1, okay. So for insert, okay. So we'll insert the element top is equal to top plus 1, okay. Increases the top by 1, okay. So we'll increase the top by 1, okay. Top is equal to top plus 1, okay. Then we'll insert the item into top position, okay. So set top is equal to item, okay. Set top is equal to item, okay. So let us explain with the example. Let us talk with an example. Okay. So for example, I'm inserting 6 elements. Okay. 1, 2, 3, 4, 5. So I'm inserting 5 elements. Okay. So let me insert some 5 elements. So 4, 5, 5, 6, 7, 4, 5, 6, 7, 1, 2, 3, 4, 1. Okay. So in this, one is the topmost element. Okay. So inserting 5 elements into the stack. Okay. Let me insert some 5 elements into the stack. So what are they are? I'm inserting 5 elements into the stack. Okay. So what are the 5 elements? 1, 7, 6, 5, 4. Okay. 1, 7, 6, 5, 4. So I'm inserting 5 elements. Observe in the stack. If you observe in the stack, మనకి స్టాక్ గాని అబ్జర్వ్ చేసినట్టే మ్యామ్ సో మనకి 1 అనేది టాప్ లో ఉందన్నమాట సో ద 1 is called as the top of the stack okay 1 is called as the top of the stack and remaining the elements okay so 1 is called as the top of the stack okay top this is called as the top okay so top of the stack and remaining elements are present at the remaining positions okay and the stack index will be keeping the track of the information okay అంటే a particular element ఏ పొజిషన్ లో ఉందనేది చెప్పడానికి మనం ఇండెక్స్ యూస్ చేసి చెప్తామన్నమాట సో బై సీయింగ్ ద ఇండెక్స్ we'll be saying that the element is at which position okay the element is at which position so we'll be saying that by using the stack index we'll be explaining at what index the element is present okay that is meant by index okay so the index will be keeping track of the information okay the index keeping track of the information of the stack okay so whatever the elements we are inserting into the stack we'll be using the index for tracking the information that is at what position the element is present we'll be saying that index is present okay that is meant by the stack element and we'll be operating the stack by using the LIFO concept okay by using the LIFO concept okay 1 second. One second, water price వస్తాను I drink water in some okay okay one drink water in some okay let us come back to class okay let us come back to class so we're inserting the 5 elements okay we are inserting the 5 elements into the stack so we are saying that one is called as the top of the element why because it is at the last position it is at the last position that's why we are calling the one as the top of the stack okay and we are using the index position we are using the elements index we are using the elements index to track the information that is if we want to find an element at which what position in the stack the index keeping track of the information on the stack okay? So index can be used for saying that at what element at what position the element is present okay and the first element is the first element is the last element the last insert element is the first element which will be removed from the stack okay so 1 is the last insert so 4 is the first insert element first we insert 4 and second we are inserting 5 and third we are inserting 6 and fourth we are inserting 7 and fifth we are inserting 1 so what is the first inserted element the first inserted 4 is the first inserted element and the second inserted element is 5 and third inserted element is 6 and fourth inserted element is 7 and fifth inserted element is 1 so 1 is the last inserted element so it will be the first element which will be removed first okay it will be the first element which will be removed first okay so this is the last element so that's why we are calling that as the top of the stack okay we are calling that as the top of the stack so one is called as the top of the stack why because the last inserted element is the first inserted element to be removed first that is why one is called as the top of the stack okay that is one important point then we'll go to algorithm okay So we are discussing about the algorithm, no? So for pop, what we'll be doing is, what is the first insert element? What is the first insert element that will be removing first? What is the first insert element? That will be the element which will be removing first. Okay, n minus one elements. N minus one elements. We will be calculating the efficiency. We are calculating the length of the stack as n minus. So for one element, first we'll take the top element first. Okay, we'll be taking the top element first, and then element from the item from the list. Okay, from the list, if we want to remove the element from the list by inserting the top element, one will be removed first. Okay, so in this case, one remove removed first, one will be removed first. Okay, and 7 will be removed second, then 7 7 will be second. Okay, 7 will be removed second, 7 will be second. Okay, second, 7 will be removed second, and 6 will be removed third. Okay, 7 will be removed second, 6 will be removed third. Okay, 6 will be removed third, 6 will be removed third. Okay, and 5 will be removed fourth. Okay, 5 will be removed fourth, and 4 will be removed fifth. Okay, 4 will be moved fifth. So for insertion also we'll be writing like this. Okay, so 4 will be inserted first, 4 will be inserted, 4 will be inserted first, and 5 will be inserted second. Okay, 5 will be second, 5 will be inserted second, 6 will be inserted third. Okay, 6 will be 6 will be 6 will be inserted third, and 7 will be inserted fourth. Okay, 7 will be 7 will be 7 will be inserted fourth, and 1 will be inserted fifth. Okay, 1 will be, 'okay? So this is called as, so if the, so first 4 will be inserted first, 5 will be inserted second, and 6 will be inserted third, and 7 will be inserted fourth, and 1 will be inserted fifth. Okay, so if the stack is full, okay, in this case, if the stack ఒకవేళ 5 elements stack full అయిపోయింది అనుకోండి, stack fill అయిపోతే next element మనం insert చేసినప్పుడు, whenever we are inserting the next element, then it will be saying that the stack is full. So then the condition will be overflow. Okay, so we కూడా పెడతాను, if the list is full. Okay, the list is, then the stack is overflow. The list is full, then we'll say the stack is overflow, And here also, if the list is empty, empty, list is empty, the list is empty, then we'll say that stack is underflow. Okay, so I'll save this image. I will be posting this image. So in this case, top is, and in this case, top is -1. Top is -1. Okay, I'll save this stack. Okay. Okay, so that is an important point. So whenever 4 will be inserted first, and 5 will be inserted second, and 6 will be inserted third, and 7 will be inserted fourth, and 1 will be inserted fifth. Okay. So if the stack is full, okay, if the stack is full, then we'll say that the stack is full. Stack is overflow. Okay. So in that case, top will become 1. Okay. Top will become 1. Top అనేది 1 అవుతుంది అన్నమాట. స్టాక్ ఎప్పుడైతే ఫుల్ అవుతుందో టాప్ అనేది 1 అవుతుంది అన్నమాట. ఆ కండిషన్ ఓవర్ఫ్లో అంటారు అన్నమాట. స్టాక్ అనేది ఫుల్ అయిపోతే కండిషన్ అనేది ఓవర్ఫ్లో అంటారు అన్నమాట. ఓకే. And in the same way, one will be removed first. So the last insert element is the first element which will be removed first. Okay, LIFO fashion lo work అవుతుంది అన్నమాట. స్టాక్ అనేది లాస్ట్ ఇన్సర్ట్ ఎలిమెంట్ will be the first element will be removed first. So what is the last inserted element? One is the last inserted element. So one is called as the top of the stack. Okay, so one will be removed. So if you want to remove the element one, we should remove the one ఎలిమెంట్ అనేది రిమూవ్ చేద్దాం అనుకున్నప్పుడు 1 అనేది ఫస్ట్ రిమూవ్ చేయాలండి. 1 అనేది రిమూవ్ చేసిన తర్వాత 7 అనేది సెకండ్ రిమూవ్ చేయాలన్నమాట. అండ్ 6 అనేది థర్డ్ రిమూవ్ చేయాలన్నమాట. 5th అనేది 4th రిమూవ్ చేయాలన్నమాట. 4 అనేది 5th అనేది రిమూవ్ చేయాలన్నమాట. 5 అనేది రిమూవ్ చేయాలన్నమాట. ఓకే, సో 4 is the element which will be removed 5th. ఓకే, దట్ ఈస్ అన్ ఇంపార్టెంట్. సో ఇఫ్ ద లిస్ట్ ఈస్ ఎంప్టీ దెన్ చేద్దాం. ఎంప్టీ అయిపోయింది అనుకోండి, మొత్తం అనేది రిమూవ్ చేస్తాం అనుకోండి, స్టాక్ అనేది ఎంప్టీ అయిపోద్ది కదా, అప్పుడు స్టాక్ని అండర్ఫ్లో అంటారు అనమాట. అండర్ఫ్లో దెన్ ద టాప్ వాల్యూ బికమ్స్ 1. దెన్ ద టాప్ వాల్యూ బికమ్స్ 1. ఓకే, సో అదే చెప్తున్నారు మన ఆల్గోరిథంలో అదే చెప్తున్నారు చూడండి. So we should check whether stack is an item to be removed first. So top is equal to 0. So then print underflow and return. Okay, set item is equal to stack of top. Top is equal to match stack. Then print overflow and return. Okay, set top is equal to top plus 1. Increases top is by 1. And set stack of top is equal to item. Stack of top and item ki assign chestunnaru. So insert item into new top list and return. So for pop also we are saying that this procedure deletes the top element of stack and assigns it to the variable item. Okay, so if we want to delete the element from the stack, and if we want to delete any item from the stack, then we'll say that the first we should check whether the stack is having any elements or not, whether the stack లో ఏమైనా elements ఉన్నాయా లేదా అని చెక్ చేసుకోవాలన్నమాట ఫస్ట్ మనం. So for that we are saying the top is equal to 0. If top is equal to 0, then we should print that stack is underflow. Okay, and return stack is underflow and return. And set item is equal to stack of top, assigns top item to item, and set top is equal to top minus 1, increases top, decreases top by 1, return. Okay, so these are the important programs. Okay, so let us run the program. Okay, so we are already having the program. మన ప్రోగ్రామ్ అనేది ఆల్రెడీ ఉంది స్టాక్ ప్రోగ్రామ్ ఆల్రెడీ ఉందన్నమాట, అది రన్ చేద్దాం. ఓకే, సో ఐ విల్ గో టు సి ఎడిటర్. సో క్లిక్ ఆన్ ఓపెన్ stack array here. So firstly I'm declaring 3 methods, ma'am. Okay, push, pop and display. Okay, first I'm writing hash include st.h, and second hash include coney.h, and hash define max 3. Okay, I'm defining the max variable as 3. Okay, so wherever in the program I can use the value of max. Okay, where max అనే వాల్యూ నేను యూస్ చేసుకోవచ్చు అనమాట. అంటే max యొక్క వాల్యూ ఎంత ఉంటుంది అంటే 3, maximum value 3 మాట. ఓకే, so first I'm writing hash include st.h, hash include coney.h, and it has defined max 3. So first I'm declaring 3 functions. Okay, void push, void pop, and void display. So these are the methods for performing the different operations. So what are the operations we want to perform on stack? So we can perform push operation, pop operation, and display operations. We want to insert the elements, we want to delete the elements, and we want to display the elements. Okay. So then I'm declaring four variables. Okay, I'm declaring four variables: int, stack. Okay, so I'm declaring four variables. Okay, stack of max top is equal to -1 x comma I. Okay, in stack of max top is equal to -1 x comma I. So I'm taking the main function. So in that I'm declaring a choice variable. Okay, I'm declaring a choice variable. I'm declaring a choice variable. Okay, so then I'm statements, that is welcome to stack operations, and then underline, and then I'm displaying the choice. I'm displaying the choice, that is if I want to perform the push operation, then I should enter the choice as 1. If I want to perform the delete operation, then I should enter the choice as 2. And if I want to display the element, then I should enter the choice as 3. So I'm printing entry or choice. Okay, I'm taking a while loop. So I'm reading the element by using the scanf function. So printf function, I'm using the printf function for displaying the statement. Okay, 1 push, 1 pop, 3 display. So I'm printing the statement by using the printf function. By using the printf function, I'm printing the statement, that is entry or choice. So I'm asking the user to enter the choice. Okay, so which operation I want to perform, which operation I want to perform. Okay, so in my C program, I'm asking the user to enter the choice. Okay, so I'm asking the user to enter the choice. Okay, I'm asking the user to enter the choice. Okay, what operation, which operation I want to perform, that's what I want to choose. Okay, so I want to select the choice. Okay, so for that I'm writing scanf %ampersand of choice, and then I'm taking a while loop. Okay, so while loop choice less than equal to 3 or not. So there are three choices: no, push, pop, and display. So there are three methods which are present. So I'm taking a choice less than equal to 3, and then I'm taking a switch loop. Okay, so for choosing which operation I want to perform, I'm taking the switch loop. Switch off, I'm passing a parameter. Okay, so here we can see that we're passing one parameter called choice. Okay, so what is the value of the choice? That will the user will enter. Okay, the user will enter the choice method, switch off choice. Then I'm writing the cases. I'm writing the cases for different cases. Case 1 push. So case 1 I'm performing. So if the value entered by the user is 1, then I will enter, then I will perform the push operation. Okay, push, break. And case 2, so if the value is 2, if the user has passed the value as 2, యూజర్ ని వాళ్ళు 2 పాస్ చేశారు అనుకోండి, పాప్ అవే ఆపరేషన్ కాల్ చేస్తాను అనమాట. 1 అనేది పాస్ చేస్తే పుష్ అనే ఆపరేషన్ కాల్ చేస్తాను, 2 అనేది పాస్ చేస్తే యూజర్ పాప్ అనే ఆపరేషన్ కాల్ చేస్తాను. సో వెన్ ఎవర్ the user passes the 3 as the value, whenever the user passes the 3 as the value, then I can call the display method. Okay, then I can call the display method. Default is exit of 0. Okay, so I'm asking the user to print f entry or choice. Okay, scanf. So after reading these statements, the user will choose some choice. Okay, either to push the element or to pop the element or display the element. So one is for pushing the element, two is for popping the, one is for performing the push operation, two is for performing the pop operation, and three is for performing the display operation. Okay, so I'm writing the switch statement for executing the condition. So three conditions I'm passing, three cases I'm passing. So for each case I'm passing one method. Okay? For each case I'm passing one method. Okay, so for case 1 I'm passing the push method, for case 2 I'm passing the pop method, and for case 3 I'm passing the display method. Okay, so after writing the choice, after writing the switch statement, I'm using the printf statement. Okay, I'm writing the printf statement / enter your choice, and then I'm asking the user to enter the choice. So after seeing the statement, what the user will do is the user will enter one value. Okay, so that value I'm reading scanf %id comma address of choice. Okay, defining the functionalities. I'm defining the functionalities. I'm writing the logic for each function. So what are the functions I'm having? Push, pop, and display. The functions what I'm having are push, pop, and display. Here we can see. We can see in the first line of the program, after st.h max3, I'm displaying the function names now. So push, pop, and display. Okay, push, pop, and display. Okay. So for writing the push operation, I'm writing top is equal to max minus 1. So I'm checking for the condition top is equal to max minus 1, and then I'm writing the printf statement. Stack is overflow. Okay, so if the condition is max 1, so what is the max value? Max value is 3. Here in the starting of the program, display it has defined max 3. So if top is equal to max minus 1, okay, I'm displaying the statement. So top is equal to max minus 1. I'm printing the statement by using the printf function. I'm writing the function as stack is overflow. Stack is overflow. Okay, so if the the stack is full. Okay, top is equal to max minus 1 means the condition is saying that the stack is full. The stack is having the full of items. Okay, full of items, and I'm writing the, so if the condition is not true, so if the condition, if the stack is not full, then I will ask for the user to enter the data. Then I will ask the user to enter the data. Printf enter data scanf percentage ampersand of x of plus top is equal to x. Okay, I'm incrementing the top variable. I'm incrementing the top variable is equal to x. Okay, so I'm assigning the value x. So I'm assigning the value called x into the plus top. I'm incrementing the top variable is equal to, and I'm passing the value of x into the variable. Okay, and then so this is the push operation. So I'm inserting the element into the stack. Okay, I'm inserting the element into the stack. So first I'm checking top is equal to max minus 1. Okay, so what is the max value? 3. So 3 minus 1. If top is equal to 2, okay, if top is equal to 2, then printf stack is overflow. Okay, so printf enter data, printf enter data, scan of percentage ampersand of x, stack of plus top is equal to x. Okay, so I'm assigning the, I'm incrementing the value of top. Okay, so in the second option is pop. Okay, pop is nothing but deleting the element. Pop is nothing but the, pop is called as a deleting of the element. Okay, so if top is equal to minus 1, if top is equal to minus 1, then printf I'm saying that stack is underflow. That is, stack is not having any of the elements. Stack is not consisting of any elements. Okay, stack is empty. So for that I'm printing the statement is stack is underflow. Okay, else, so I'm printing the popped file. The popped item is stack of top minus 1. So here for the pop operation there is no need for entering any number. Okay, so directly the immediately it will take the top of the element. Okay, ఇక్కడ మనకి ఇన్సర్ట్ ఆపరేషన్లో మనం చాయిస్ అనేది పాస్ చేసాం కదా, ఏ ఎలిమెంట్ అనేది డిలీట్ చేద్దాం అనుకుంటున్నాము, కానీ పాప్లో మాత్రం మనం ఎలిమెంట్ అనేది పాస్ చేయమంటే డైరెక్ట్గా ఆటోమేటిక్గా డిలీట్ చేసుకుంటుంది అనమాట. అరే స్టాక్ దానికంతా దానే అరే ఎలిమెంట్ అనేది డిలీట్ చేసుకుంటుంది అనమాట. ద స్టాక్ విల్ డిలీట్ ద ఎలిమెంట్ బై ఇట్ సెల్ఫ్. సో దెర్ ఈస్ నో నీడ్ ఫర్ పాసింగ్ ఎనీ ఎలిమెంట్ ఫర్ ద పాప్ ఆపరేషన్. ఓకే, so directly it will display that statement as the popped item is percent stack of top minus 1. Okay, so I'm decrementing the value of top. After deleting, I'm decrementing the value of top minus 1. So if the value of the top, if the length of the top stack is 5, then it, after deleting the element, it will become 4. 5 becomes 4. Okay, 4 becomes 3, 3 becomes 2, 2 becomes 1. And if it is 0, then it will say that stack is underflow. If top is equal to minus 1, stack is underflow. And then the third method is called as void display. Okay, void display. So I'm checking for if top is equal to minus 1. Okay, stack is underflow. Okay, or else if the items are present, then I will display the elements by saying the contents in stack are, the contents in stack are, for I is equal to 0, I will greater than is equal to I minus printf slash n percentile d stack of I. Okay, so we can observe the program. So in this observing the program, what I, how many methods I'm writing? I'm writing 3 methods. Okay, I'm writing 3 methods. So what are the methods are? First one is, what are the methods are? First one is push operation, second one is pop operation, and third one is display operation. Push operation, pop operation, and display operation. Okay, I'm displaying 3 methods. Okay, and then I'm writing the switch statement for displaying the choice. Okay, so whatever the number, whatever the choice the user is, so I'm displaying the enter your choice. So after that, the user will enter some number. That element I will be reading that and will be scanf. So I'm writing the printf statement for displaying the statement called enter your choice, and then I'm reading the element by using the scanf function. Okay, by using the scanf function, I'm reading the element. Okay, scanf percentage at the rate of choice. Okay, at the rate of choice. So while choice less than equal to 3, switch off choice. Case 1 push break, case 2 pop break, case 3 display break. Okay, okay. So that is the important point. And break. Okay, printf enter your choice. Okay, scanf percentage at the rate of choice, get ch. So I'm declaring 3 methods. Okay, push, pop, and display. Okay, so whenever we want to pass an element, directly we can pass the element into the while loop. Okay, into the while loop, into the switch element, I want to pass the element. So in the starting of the program only, I'm using the printf function. Okay, I'm using the printf function for saying that enter your choice. Okay, and then I'm using the scanf function for reading the element. I'm using the scanf function for reading the element, whatever the user will enter. Okay, so after that, I'm taking a while loop, while choice less than equal to 3, and then switch off choice. Okay, and then switch off choice, and then I'm displaying 3 methods. Okay, push, pop, and display. Okay, so I'm displaying the, if the user has entered 1, if the user has entered 1 for the enter your choice, then I will call the case 1. Okay, if the user has entered 2, then I will call the case 2. If the user has entered 3, I will cause the case 3. So 3 cases I'm passing. Okay, so one case is for push operation, one case is for pop operation, and so case 1 I'm writing case 1 push open brackets and close brackets semicolon break, and case 2 pop operation open brackets close brackets break semicolon, and case 3 display operation display open brackets close brackets semicolon break. And then I'm writing the default statement. So I'm passing the default statement. Default is equal to exit of 0. Okay, that is very important. అర్థమైంది కదా మేము ప్రోగ్రామ్. సో I'll run the program. Okay, I'll compile the program. The execution of the program. Okay, so compile. So there are 0 errors and 0 warnings. Okay, there are no errors. There are no errors. 0 errors and 0 warnings. I want to run the program. Okay, see, firstly, welcome to stack operations. 1 push, 2 pop, and 3 display. So enter your choice. So I'm asking the user to enter some element so that I can perform as per this. So if the user enters 1, then I will perform the push operation. If the user has entered 2, then I will perform the pop operation. And when the user has entered 3, then I will perform the display operation. Okay, so let us enter the, so I want to insert some elements. I want to insert some 5 elements into the stack. Okay, I want to insert some 5 elements into the stack. Okay, so I will enter the push operation. I want to call the push operation. Okay, so what is the number for the push operation? 1 is the number, so I should enter the 1 here. So I will enter the 1 here. So I will enter the 1 number. So click on enter. So after click on enter, let us see what will happen. See, it is asking for enter data. So enter the elements what you want to insert into the stack. Okay, I enter the elements what you want to insert into the stack. So for example, I enter the 1. See, again enter your choice. So one got inserted, one element got inserted. Enter data, one element got inserted. So I pressed enter, then again immediately it is asking for, again it is asking for choice. Again I want to insert the element. Okay, again I will choice 1. Again it is asking for the data 2. Okay, 2. Okay, so enter your choice. Again I want to insert element 1, 3, and 1. Stack is overflow. Okay, stack is overflow. So enter your choice. So I will click on 3 to display. Comments, the contents in stack are 1 2 3. Okay, 1 2 3. The contents in stack are, again, so I'll try to remove the element. Okay, 2. Enter your choice. The contents in the stack are 1. The popped item is 2. Okay, enter your choice. 2. The popped item is 2. Okay, 2. So enter your choice 0, 3. Okay, understood now? Understood now? అర్థమైంది కదా ప్రోగ్రామ్? హలో,
Yes, sir.
అర్థమైంది కదా ప్రోగ్రామ్? దట్ ఈస్ ద ప్రోగ్రామ్ ఫర్ ద స్టాక్. ఓకే, ఫర్ ద స్టాక్ యు ఆర్ రైటింగ్ ద ప్రోగ్రామ్. ఓకే,
Okay, sir.
మళ్ళీ చూడండి కావాలి. Enter your choice. See, 1 1 choice again 1. Your choice. Stack is over. Stack is overflow. So it is saying that stack is full. So 3 elements are inserted. Okay, 3 elements are inserted. So it is saying that the stack is full. Okay, so I will display the elements. Okay, the contents in stack are 1 2 3. Okay, 1 2 3. So enter your choice again. Enter your choice. Again, if you want to delete the element. Okay, again if I want to delete the element, enter your choice. The pop item is 2. Okay, the contents in stack are, I will display the statement stack are. Okay, so I'll post this. Okay, I'll post this program. I attached the program name. Afterwards, you can practice the program. Stack program I have written. Okay. So let us go to the next concept. So this is the program name. Okay. This is the program. Okay, let us discuss about the applications for a stack. Okay, let us discuss the applications for a stack. So the applications for a stack are stacks are used in conversion of expressions from infix notation to postfix and prefix notation. Okay, stacks are used in conversion of expressions from infix notation to postfix and prefix notation. Okay, stacks are used in conversion of expressions from infix notation to postfix and prefix notation. And second application is stacks are used for evaluation of infix and postfix forms. Stacks are used for evaluation of infix and postfix forms, and stacks are used in tree traversal techniques. Okay, stacks are used for tree traversal techniques, and recursive functions are implemented using stacks. Recursive function. So what is meant by recursive function? It is meant by the, so it is the function which calls itself. Okay, recursive means it is the function which calls itself. Okay, recursive functions are implemented using stack. Okay, and compilers use stacks in syntax analysis phase to check whether a particular element in the program is correct or not. So we will be checking the syntax of the program, and then we'll be saying that whether the particular statement in a program is written in a correct format or not. Okay, is a syntactically correct or not. Okay, compilers use stacks in syntax analysis phase to check whether a particular statement in the program is syntactically correct or not. Okay, and stacks are used in depth first search of a graph. Okay, stacks are used in depth first search of a graph. So that is when by stack mem. Okay, stack is finished. Okay, that is our stack concept. So let us go to the next concept called queue. Okay, let us go to the next concept called queue. Let us go to the next concept called queue. Okay, let us go to the next concept called queue. Next we'll go to the queue concept. Okay, so basically queue is also same like stack only. So queue is a kind of data structure where we can store list of elements. Okay, where we can store list of elements, and each element in the stack will have an index. Okay, each element in the queue will have an index, and this index will be keeping track of the elements in the queue. Okay, is this okay? So a queue is a kind of data structure where we can store list of elements. Okay, queue is a kind of data structure where we can store list of elements. Okay, where we can store list of elements, and each element in the queue will be having one index. Okay, that index will be used for keeping track of the elements in the queue. Okay, and in our queue every element will be inserted in only one end, that is called as front end array. Here we will not have any head and tail, we will be having front end array. Okay, we will be having front end array, we will be having front end array. Okay, we will be having front end array. So in our queue every element will be inserted and deleted one end, that is showing a queue will be having front end array. Okay, they will not having any head of the element or top of the stack. That front and rear. A queue will be having two things. Okay, queue will be having two things, a front and a rear. Will be having two things, a front and a rear. Voice breakout. No. Okay, fine. So this index will be keeping track of the elements in the queue, and in our stack, every element will be inserted and deleted only one, and that and is called as a front and a rear. Okay. So and also queue will be operated in the form of first in first out. Okay, first in first out basis. It is not last in first out. It in first out basis. First in first out basis. So FIFO. We'll be saying that as FIFO. Okay, first in first out basis, which means the first inserted element is the first deleted element which will be coming out. Okay, the first inserted element is the first deleted element in the queue. So every queue in our element will be having two operations. Okay, DQ and NQ. Okay, DQ and NQ. For inserting the element, we will be calling that as NQ. And for deletion of the element, we will be calling that as DQ. Okay, NQ and DQ. Okay, this operation is used for inserting an element into the queue, and DQ operation is used for removing an element from the queue. Okay, so the remove operation on the queue is called in the reverse order that the elements are inserted. Okay, stack index will be keeping track of the information of the stack. After inserting the elements in the stack, if the queue is full, then we'll say that the condition is overflow. Okay, here also we'll be having two conditions. Condition is overflow and condition is underflow. Okay, so I'll be taking out. So algorithm for a queue we'll be discussing. Okay, so algorithm for a queue is inserting an element into a queue. Okay, so I'm calling the queue insert method. In that I'm passing four parameters. Okay, queue, n, front, rear, and item. Okay, queue is the list of elements I'm passing. N is called as the passing element, and front is called as the front element, top element, first element, and rear is called as the last element, and item is the item I want to search for. So first I should check whether queue is already filled or not. So for that I will be checking if front is equal to 1 and rear is equal to n. Okay, if front variable is equal to 1 and rear is equal to n, or if front is equal to rear plus 1, then write overflow and return. Okay, then write print the condition as overflow and return. So find new value of rear. Okay, so if front is equal to null, then queue initial empty. Set front is equal to 1 and rear is equal to 1. Else if rear is equal to n, then set rear is equal to 1, else set rear. So here I'm checking for the different conditions. Okay, so firstly I'm checking for the overflow condition. So I'm checking whether if front is equal to and rear is equal to n. If front is equal to 1 and rear is equal to n, or if front is equal to rear plus 1, then write overflow and returns. Then find new value of rear. Okay, so queue initially is empty. Okay, queue is initially empty. So for that I'm passing the null value. Okay, if front is equal to null. So I'm checking for the null value if the queue is empty. Okay, then I'm passing the front as 1 and rear. So I'm passing the value called 1. I'm assigning the front as 1 and I'm assigning the rear as 1 if the queue is empty. Else if rear is equal to n, then set rear is equal to 1. Else set rear is equal to rear plus 1. Okay, end of if structure. So set q of rear is equal to item. This inserts new element and return. So I'm inserting the element by writing the statement called set q of rear is equal to item. Okay, this inserts new element. And for deleting the element also, I'm writing the q delete method. So q comma n comma front comma rear comma item. Okay, so I'm passing the q elements. I'm passing the n number of items. I'm passing the front rear item. Okay, so q already empty. So I should check further the q is already empty or not. Already empty or not. Empty or not. So I will be writing front is equal to null. Then write underflow and return. Okay, I will be printing the statement as underflow. I'm passing the condition as underflow and return. So set item is equal to q of front. Find the value of front. If front is equal to rear, then q has only one element to start. Okay, if set front is equal to null, rear is equal to null, else if front is equal to. So these are the condition, ma'am. These are the conditions we are passing. So this is the algorithm for writing a queue and for writing a algorithm for performing a queue. Okay, so inserting an element and deleting an element from the queue and assigning it to the variable item. Okay, so I'll post this algorithm also. I'll post this algorithm also. Okay, so we'll go to the program. Okay, we'll go to the program. So click on file, click on open QR. Okay, so I'm taking three methods. Okay, firstly I'm writing hash include stu.h, hash include conio.h, and hash define max3. Okay, so void insert, void delete, void display, int q of max, front is equal to 0, rear is equal to -1, x comma I. Okay, again I'm taking four variables. Okay, q of max, front is equal to 0 and rear is equal to -1, x comma I. So I'm taking a main method of void main, and in choice I'm taking a variable called choice variable, and I'm displaying the statements. Welcome to q operations. Welcome to Q operations. So insert, delete, and display. Okay, insert, delete, and display. I'm displaying the statements called insert, delete, and display. Firstly, I'm writing the program for performing. Firstly, I'm writing the programming for performing the Q operations. Okay, that is NQ and DQ for inserting the element and for deleting the element. For inserting the element and for deleting the element, I'm writing the program. Okay. So firstly, I'm using the printf function. I'm using the printf function for displaying the statement called welcome to Q operations, and then I should display the choice. I should display the choice of the elements. That is 1 as insert, 2 as delete, and 3 as display. Then printf enter your choice. Okay, enter your choice. So scanf percentage ampersand of choice. Okay, so while choice less than equal to 3, choice less than equal to 3. So here I should choice. So switch off choice. So case one insert. Okay, so I'm passing the case one. Okay, case one as I'm firing the case one. I'm calling the case one as insert method. I'm writing the case two method as delete method. I'm writing the case three method as delete display method. Okay, so display method. So I'm writing the enter your choice. Okay, I'm asking the user to enter the choice. Okay, I'm asking the user to enter the choice. So scanf percentile ampersand of choice. Okay, get ch. So I'm taking the insert function. I'm taking the insert function void insert. If rear is equal to max minus 1. If rear is equal to max minus 1. So I'm checking for the condition, that is q is full or not. Okay, q is full or not. So I'm checking for the condition. Okay, so rear is equal to max minus 1. So printf q is full. Okay, if the q is full, if the condition is true, if rear is equal to max minus 1, that is what is the max value 3. So 3 minus 1 2. If rear becomes 2, then I will print that q is full. Okay, or else if it is not the condition is not satisfied. Okay, if the condition is not satisfied, then I'll print the enter data. Okay, enter data, scanf percentile d ampersand of x, q of plus plus rear is equal to x. Okay, and then I'm initialize the front to 0. And for delete operation also, I'm taking the condition called rear is equal to -1 or front greater than rear. If rear is equal to -1, okay, if rear is equal to -1 or front greater than rear, then I will say that q is empty. Okay, for delete operation, I'm saying that q is empty. So q is empty is the condition I'm checking for. Then I'm checking for the condition if front double is equal to rear, front is equal to rear is equal to -1. Okay, else front plus plus. So void display for a is equal to front, I and is less than is equal to rear, I minus minus printf for slash and percent q of I. Okay, q of I. So I will run the program. Okay, first I will compile the program. There are 0 errors and 0 warnings. So I will run the program. So enter your choice. Okay, 1. Enter data 1. 1. 1. Q is full. Okay, so enter your choice. So if I display 3, see 1 2 3. Here we are having 1 2 3. In the last three elements, we are having 1 2 3. So if I, okay, Q is full. Okay, understood? No, understood కదా, ప్రోగ్రామ్ అర్థమైంది కదా? హలో హలో ఓకే మేము అర్థమైందా? Okay, that is our program. So I will post this program also. మీరు కూడా ప్రాక్టీస్ చేయండి మేము ప్రోగ్రామ్స్, మీరు కూడా ప్రోగ్రామ్స్ ప్రాక్టీస్ చేయండి. ఓకే ఓకే ఓకే. Okay.